Bien, je vous propose de commencer le séminaire. Merci d'être venu écouter donc, le second exposé de notre professeur invité, Andrea Moro, qui est professeur à l'Institut d'études avancées de Pavie. Et avant de commencer, je voudrais dire quelques mots que je n'ai pas dit la dernière fois, pour mentionner en particulier que, si cela vous intéresse, Andrea Moro est l'auteur de nombreux livres. Et je voudrais mentionner particulièrement deux d'entre eux. L'un qui est assez technique, qui a eu un grand succès dans la discipline de la linguistique formelle, qui s'appelle Dynamic Antisymmetry, mais qui est réservé à ceux d'entre vous qui maîtrisent, disons, les concepts avancés, dans la mesure où il s'agit d'une réponse, d'une continuation avec des idées très originales du livre de Richie Kane, de Antisymmetry of Syntax. Et il s'agit en quelque sorte d'une réponse, d'un prolongement de ce travail. Et puis il y a un autre livre qui est alors beaucoup plus accessible, qui s'appelle The Boundaries of Babel, donc le titre de l'exposé d'Andrea la semaine dernière, qui passe en revue justement la question de savoir comment on peut mettre en relation l'apprentissage des langues et les contraintes apportées par la grammaire universelle avec les études d'imagerie cérébrale. Donc un livre que j'ai trouvé personnellement très intéressant, qui n'est pas traduit malheureusement, mais qui est disponible en anglais. Andrea est aussi l'auteur de plusieurs livres en italien, que nous espérons bien voir traduire un jour, non pas trahir un jour, pardon, qui porte en particulier, le tout dernier qui vient de sortir, porte sur une toute petite histoire des concepts de la linguistique à travers les âges. Je crois que ça va depuis Dieu jusqu'à Chomsky. Une petite provocation.
In 17 steps.
En 17, il faut seulement 17 ans.
Seulement 17.
Avant de commencer, cher Andrea, comme tu es professeur invité au Collège de France, il y a une récompense, une médaille, un souvenir de ta visite. Et donc, je suis très heureux de te présenter cette médaille du Collège de France qui porte le bâtiment et la date de ton exposé. Merci beaucoup.
Oh, thank you so much. Now well, okay. If I was scared to speak in front of you, and I'm much more scared. Thank you so much for your introduction, for everything you said for this. I'm going to keep in my pocket. They're not very nice. Okay, so in today's talk, I would like to address a different issue. As scientists, as human beings, whenever we see something that is endowed with an organization, we always ask the same question. Is the organization coming from inside the object we see, or is it the reflex of something else? You know, taking advantage of this PowerPoint facility and Caravaggio that we'll compare in terms of beauty, we could ask whether the structure of language is in fact the reflex of some other structure that stays in the external world. In fact, there has always been a sort of a constant tension in the history of linguistics with respect to two possible answers to this question, whether or not the language is importing instruction from outside. There is a first obvious way of saying that grammar is the reflex of the external world on the human mind, as in the case of number or of pronoun. So, for example, if I show you this, and you call it a bottle, bottiglia, bouteille, and if I show you two of these, you immediately recognize they're the same, even if they're not exactly in the same shape. The retina is not exactly getting the same image. But what you do in your grammar, you provide the word with a marker that says, well, I have more than one object, which is plural, what we call plural. In that case, it is obviously the case that we want to say that what grammar has in is the reflex of our cognitive capacity to recognize things in the world. Same thing with pronouns. If I say I and I say you, it's because I perceive myself as a unit which is distinct from the other units that I'm seeing as. Now, of course, the question is whether the whole grammar can be reduced to the impact of the external world. There is an opposite way, as if the pendulum is shifting between two opposite poles. It is to say that the core structure of grammar is the result of specific instruction which cannot be inferred from the external world. Needless to say, this constant tension is not one that has been born very recently. In fact, there is a major enterprise, which I'd like to quote here for an obvious reason, that can be synthesized with a famous quotation. Grammar is one and the same in all languages by nature, although there may be accidental variation. You probably all know that if I had to pronounce this citation in the original language, I would have said grammatica una et eadem est secundum substantiam in omnibus licet, or licet, as the proper pronunciation would say, accidentalitas varietur. This thing was pronounced by Roger Bacon in the late 13th century. In fact, Roger Bacon taught here in Paris in 1237. He gave a course at the Faculté des Arts. I don't know where that was, probably close to here. He didn't have a medal, but he was brave enough to go and get that. So, there were moments in the history of thought where it was strongly believed that the shape of our grammars reflected our cognitive capacity to understand the world. And since we only have one cognitive capacity, there was an immediate consequence of that attitude. That was to say, there is just one grammar. The superficial things that you see are only due to accidental facts. Actually, the link between cognitive capacity and expression was granted by God. So I would perhaps stop with the first characters, the small book that I wrote. But of course, this aspect, these theories now are untenable as is, even if the consequences are, in a sense, still interesting. And they are so interesting, and this is a sort of anticipation of what I would like to address at the end of this talk, that have been sneakily, I would say, brought back into the arena by suggesting, for example, that language can be seen as sort of an emancipated motor control system, as was suggested by Corballis in a famous paper where he was trying to say that the mirror neural system is the engine that drives evolution with respect to language. I will go back to this issue and to be clear in the next steps. But one thing that I would like to do before getting into the argument is just try to summarize briefly what we know already about the relationship between grammar and the brain. That is, I would like to make a very short summary of what I said last time, perhaps in a different fashion. We know that, just playing with words, there are two ways of looking at the boundaries of Babel, that is, at the limits of the alleged chaotic system that language system should be. One is to see linguistics as a sort of a theory of the limits of experience on grammar. This has to be made very clear. It is, of course, the case that experience influences grammar. It influences grammar, and in fact, language, because of the fact that I'm saying bottiglia and I'll say bouteille or bottle, or it could be influenced because I use one system of declension or the other. But one important thing to say is that modern grammar just aims at construing what could be the formal limit of variation of grammars. And on the other side of the coin, we have neurolinguistics, which aims at naturalizing these limits as the effects of the neurobiological architecture of the brain. So these two parallel tracks, in fact, cannot ignore each other, at least not in the present time, and sort of constitute the main path toward our modern, what do we mean by our modern understanding of language? Invariant phenomena across languages have been explored the last 50 years in so many aspects that it could be hardly doubted that there is so. One, actually, citation that I better not read here is given by Luigi Rizzi in a famous paper where he said language variation is construed in severe and systematic ways. This paper appeared in a recent, well, not so recent, it was 2005, in a paper where things were compared in a very selective and highly constrained way, and he showed in his paper that the amount of knowledge we have so far by understanding the language system as endowed with limits are much more advanced than in any other possible times of the history of linguistics. Well, of course, the other track goes on a different kind of empirical evidence. It's not a formal system. For example, it uses the notion of impossible language. It is a language that does not correspond to any of that goes beyond the boundaries of the formal limits that have been discovered in terms of comparison. Just focusing on experiments that I had the fortune to take part in, I will name 3 of them. There was one experiment where the neural correlates of the acquisition of natural language synthesis were explored. Another one that corresponded to the analysis of impossible rules in actual languages. And then a final one where instead of languages, strings of abstract symbols that could not be named were used in order to make the comparison work. One of the last slides of last time's talk actually was the fact that when the brain computes possible versus impossible languages, that is again languages which lie either inside the possibility of variation of language that have been isolated in terms of comparison or outside, we have a very different behavior of one point of the complex network that constitutes the network related to language. So the thing here can be read as follows. You have the accuracy and blood flow in Broca's area, and then you see here the real dissociation with possible rules. The better you get, the more accurate you get, the more amount of blood and energy is required. With impossible rules is the other. One thing that I did not show last time was the actual experiments, and discussing it later with Professor Dehaene, it was interesting to notice that completely involuntarily, but in this first paper, we show distinct cases. So disregarding by now the complex number system that is used here, you see here again, so for example, take this subject, the better he was doing with possible rules, the more the more blood and energy was used in Broca's area, and vice versa with impossible rules. Same thing happened with Japanese, because the experiment was run twice. The German native speaker had to learn Italian and Japanese, and we hide within the system of rules impossible rules, and we saw what the reaction of the brain was. There are very many questions that are open by this kind of pattern. The first immediate question you see here is probably obvious immediately to you, is the fact that the first, the white dot starts higher than the black dots. And we didn't understand why. Honestly speaking, we didn't have any explanation for that. But this is consistent. And this is not only consistent in this experiment, but in other 2 experiments that were done, where instead of teaching them impossible rules made of true words, we used pseudo sentences, and there was no teaching. The subject had to understand the languages by seeing the examples. In this case, we obtained similar results. As you see here, the subject, for example, let's say this first subject, instead of dots, here you have the black column or the gray column, the light gray column. You see that with the possible rules, you had more energy, the more you get inaccuracy, and vice versa with impossible rules. But still, the first discrepancy is evident. And again, it's one of the mysteries that we hope will be uncovered by someone else. The third experiment was just playing with another kind of stimuli. Instead of using agreement, let's say, like the typical subject-verb agreement, subject-predicate agreement, we used agreement in terms of color. So playing with the words and mimicking them with a color, we said that there was a rule that said that, well, when you have a certain element with a certain shape, certain color, we had to have 3, 4, 6 steps after, but in a fixed number, the same element. In the other case, they were free to be organized as close or as far as possible. Again, also in this case, we had the same result. So in all these cases, we had the experiment converged to the idea that the limits that were observed in terms of comparison among languages, let's say the boundaries of Babel in a formal way, corresponded in a naturalized way in a sort of a phenomenon that was really built in the brain structure that corresponded exactly to the activation of Broca's area. So we can actually go back, knowing this, we can go back to the fundamental question and ask whether the idea that our language is shaped from the intervention, the imitation, or the impact of the external world on our brain is still a good question or is still alive. Actually, in the citation that is given here, there is a very strong claim. The idea is that mirror neurons are, in fact, as I said, the powerful engine that led to the human grammar. As you see here in the abstract, the author argues that the language evolved from manual gestures, initially as a system of pantomime and so on and so forth. Well, this is surely an interesting issue and one that deserves our attention. But we have to make sure that a priori, all the phenomena can be reduced to this. Because, as I said before, I'm not denying the fact there can be aspects of the external world that can be incorporated in our system of communication. What I'm saying is whether the core aspect of our language can be copied from the structure of the outside language. Just to make clear a simple thing that I take it obvious to most of you, or perhaps all of you, the mirror neuron system has to be considered as a phenomena where certain network in my brain that I would use to do a gesture with a certain intention are active also when you see someone else doing the same gesture with the same intention. I want to emphasize that. Gesture and intention. So if I suppose, for example, this is fake because this is not a pen. In fact, you know it's a pointer. But suppose it was a pen and I had to sign something. If I do this, you obviously understand what I'm doing. I'm grasping the pen to sign something. If I were taking this and doing this or this, you wouldn't understand that. What is he doing? He's eating a pen. So only in the first case, your system would mirror my active production, because you have to understand the intention of the gesture that's behind that. I'm saying that because of the fact that the more you explore the core aspect of grammar, the more the hypothesis that the mirror neural system can be the engine of evolution of language, it becomes fragile, and at certain points, at least to me, becomes totally undermined. In fact, we're facing, first of all, two radical sub-questions, and one that I would like to address here. When it comes to the existence of language and syntax, that we have seen is the real fingerprint that distinguishes humans from all other living animals, we have two sub-questions. First, a radical question is, why do we have syntax? Why do we have compositional rules instead of having just all possible combination of words as interpretable? Sometimes when I give classes to the first year student, I used to make this simple comparison. Suppose that Italian consisted of only two words, John and arrives, Gianni e arriva. How many Italian sentences can you make with that? You can make two, because you can say arriva Gianni, Gianni arriva, Jean arrive, arrive Jean. Now in French and English, you can only make one sentence. So you can only say, for example, I believe that John arrives. You can't say, I believe that arrives John. So in a sense, Italian apparently is able, with this minimal, very minimal grammar, to construct more sentences than another language. More sentences is more information, more communication. Why isn't it the case that there are languages where all combinational words convey meaning? There is a sub-question, and I will follow this path for a moment, but there is a sub-question which pertains to the major issue that I'm addressing here. That is, why this syntax? And by this syntax, I have to show the major property of syntax as I mean it. So let's take the first path first. Why syntax? That is, why aren't all combination of words interpretable by the brain, as in the quasi, very minimal Italian that I was using? Well, I would like to suggest that asking this question would be exactly like asking, especially in a rainy day, why the rainbow? How come that the grammar and the rainbow can be connected together? Well, you could rephrase the question why the rainbow asking why aren't all the radio wavelengths visible to the eye? After all, we perfectly know that we're just using a tiny slice of the potential full range of radio wavelengths. In fact, our retina is a sort of a selective organ. The human retina, in fact, is sensitive to only a small range of electromagnetic waves. If you see here of all the possibilities, you see that, for example, the rainbow slice is very tiny here. You have ultraviolet, X-rays, and gamma rays on the left, and infrared microwaves, and then FM and AM radio waves and long radio waves. Would it be better for us to have an eye that sees all the frequencies? Well, suppose we could see, for example, suppose there is a mutation in a human, and then all of a sudden we are able to see infrared light. Would it be useful? Of course. For example, we wouldn't get burned by touching a hot teapot. Or in the dark, we could see warm blood animals coming close to us. This is a non-question in biology. You never ask whether something would be better or not. Everything has to be set in terms of equilibrium. But suppose that a mutation increases and you use all the possibilities to see everything around. Then wavelengths will become completely unuseful, because between the two of us, for example, we would have all the TV channels, our mobile phone communication. If someone is heating water in that room, we had, what do you call it, the infrared information, and so on and so forth. So it's clearly the case that an unbounded sensitivity will make it impossible to use signals to get information, as if you were opening the TV on a dead channel. Interestingly enough, when you look at that, you immediately associate that to a sound, which is the white sound, right? The one that covers everything. This is sometimes one of the most strange onomatopoeic universal in language. When you have to tell someone to be silent, you always say shh. You never say toot or something like that, just because you want to cover all the possible signals. And that's another. This is a functional linguistics in a very concrete sense. Anyway, if you think that the theory of the reason why we see only a tiny slice of color is useful because when we open our eyes as kids, in fact, it took a little number of months to get that. But at least we were able to see if the organ were properly formed. We were able to see our mother, our father, the persons around us face, and so on and so forth. So I am able to move around objects and so on and so forth. Similar thing may happen to grammar. Grammar could be just considered as filters. The reason then why the brain is sensitive to only a limited types of grammars may be similar to the case of vision. Too much information may render grammar unusable or unattainable by children. That is to say, nature sometimes is parsimonious because the same message repeated twice may make things completely ununderstandable. So if the first question is why syntax, then the answer could be syntax is a filter of possible combination that reduces the space of computation for kids to learn it. In other words, no matter what syntax, but some syntax, as if we were not able to see the rainbows, but only, let's say, radio waves of other kind. We could think of a possible world where things would work in a similar way. We don't know what are the reasons that have selected this syntax, though. But it doesn't seem unreasonable to assume that some syntax is required in the first language acquisition by children, which otherwise could be impossible. But then there is a major question, and this question relates back to our first issue. That is, why do we have exactly this grammar in the brain? That is, why do we have these limits in the brain? Are they taken from the structure of the world or not? And I am addressing that. Of course, I want to make a deal with you. We obviously know that I'm not going to answer to this question by the end of the talk. I'm just trying to address and select possible answers or possible questions, in fact. But let's go toward that. In order to understand why this syntax and not another one, we first have to uncover the basic property of syntax. Because otherwise, how could we know whether the rules of our syntax can be copied from the outside world? There is a preliminary step that we have to make. This is very typical when you speak about language to non-linguists or maybe to linguists. I don't know, it depends on the kind of linguist you meet, right? So it's as if the partition doesn't make any sense. But let me give you two examples. In the two examples that I'm giving you, I would like to ask you if you see a reason why one sentence is good and the other is bad. A reason means whether you see a logical reason for that. Take these two sentences. Who does not want to meet before hiring an Italian? Who does not want to meet a nun before hiring? You immediately know that the second sentence is bad. What is the logic beneath this contrast, behind this contrast? There's no logic. Linguists have been it was, I think, discovered in the early 70s, probably in the early 70s, and ever since then, people have struggled to understand the reason why certain structures are good and certain are not. This is what is called locality theory. And in fact, again, for example, in Luigi Rizzi's work and in others' work, like Jim Huang works, the conditions were established where things could be expressed or not. But again, even if you try it very hard, it would be very strange if you find any logical reason why the first thing in terms of communication perhaps is good and the second is not. There is a recent paper that I think I mentioned even in the first talk that also produces a sort of a segment of the other path. It's a paper done under the supervision of Daniel Osherson, and it's an extremely interesting paper that has at least two effects. The first is that it compares logical errors made with words with grammatical errors, and it shows that the activation of a brain network with logical errors without grammatical errors is completely different from the activation of grammatical errors. And the second thing, which is only prodomomea fact, is that they observed the activation of the left nucleus caudatus, which was one of the elements constituting the net for the language. But the first thing is much more interesting. Okay, so let me make a sort of a summary here. We addressed the first question, whether or not we can think that our grammar is copied by the structure of the outside world. Then we said, well, there have been, in the history of linguistics, times where people suggested exactly this. But in recent times, it has been suggested that the mirror neural system, in fact, is a positive answer to this question, one that says that you do have, that your motor control system lies at the very heart of the grammatical system and makes the sort of an internal seed that gives the possibility to have the whole system work. I used this slide last time. I'm particularly fond of it because of the fact that it appears not to be expected in this talk. When I was a kid, I had one of the perversion that I had was to look beneath the tapestries in museums and see where were the lines of color connecting points. And in fact, if you see, for example, this sort of a simple tapestry, you see red dots here and red dots here separated by dots with different colors. And then apparently it is unrelated, but it is sufficient to turn the things up, let's say, from one face to the other, and you immediately see what the relationship between long-distance element was. So the work of a linguist is, in a sense, to look behind tapestries and see where relation between apparently distant things, in fact, takes place. To understand that, and now I go really quickly because this is just a quick summary of what I said before, is that linguists do need that because of simple contrasts like the following one. You know that John runs is a possible combination of words. They're both singular. John run is not. But if you put extra words beyond these two, the sentence becomes again correct. So the sequence John run, you cannot say whether or not it's grammatical unless you compute the whole syntactic environment where it is immersed. And to understand that, the linguist designed special way of representing this fact in a bidimensional case. The fact that you need to have at least two dimensions is just given by the fact that one single dimension linearity wouldn't be enough because of the fact that these two words, John and run, don't match, but there is an extra word. So you have to add the extra dimension that contains the information of the extra element that is first to the right. If you have this kind of molecule made out of words, then it is very easy to interpret these phenomena. So, for example, John run is a simple rule that says that a verb phrase, that is a group of words that pertains to a single, like in a small solar system, to a single word which is a verb, agrees with a single word of the noun, and say John runs. Same thing when you say those who love John run, but you cannot have agreement in between these elements. Let me go a step further, but remind that I have to convince you of the impossibility of an explanation in terms of mirror neuron system in case of this of syntax. So, for example, if I have a sentence like the following one: una foto di questo muro ha causato la rivolta di quella città. A picture of the wall has caused the riot of that city. In this case, I put just X instead of N, V, that is for a noun, verb, just to have a sort of a general abstract representation of elements, and you see immediately that the same structure repeats itself on the left and on the right branch of the structure, as if it were including the topmost structure, as if it were a sort of a quasi-autosimilar structure, where autosimilarity is the property that in mathematics and geometry you have when a certain element, a part of an element, contains the same information as the whole, right? This is just, the formula, a structure that can be computed by merging together elements and recursively and construct a strong structure. A bigger structure. One of the things that Stan mentioned during his introduction was the work by Richard Kane, who actually promoted one of the largest and more debated stream of analysis in modern linguistics. That is the principle of antisymmetry. It could be sort of hard to describe it in formal terms, but I want to give you at least the flavor what is meant by antisymmetry principle. Suppose that this is a tree valid in some language. Then the principle of antisymmetry says that if that is valid, the mirror image of that tree is not valid in any other language. This is, in a nutshell, a non-formal way of expressing the theory of antisymmetry. Now, why did I give you all this information concerning hierarchy? I told you that we sneak beneath the structure to look at the elements, and I showed you that we have the bubbling system where a structure contains the structure that contains the structure, and then I showed you that I mentioned at least to you that we have this antisymmetry principle because of one immediate fact, that when we speak, and when we hear, we put words into a linear sequence. And linearization makes hierarchy invisible. There is quasi-autosimilar, that is hierarchical structure, recursively hierarchical structure, are hidden because the physical structure of the human code is always manifested as a linear sequence of morphemes, including sign language. Now, if this is true, remember the major dogma of a mirror neuron-based theory of acquisition. The mirror neuron is the activation that you have in your brain when you see someone doing something with a certain intention. Now, if hierarchy is what constitutes the core aspect of syntax, the only thing you can see me doing is the construction of a linear sequence, then what can you mimic? Hierarchy disappears, is invisible to the stimuli. So how could that be that in your brain you have a mirror-like reaction, mirror neuron-like reaction to the system? Does it mean that we have to give up for the second question? Remember, there were two questions. Why syntax? Why this syntax? Well, yes and no. Playing with words, I wrote a very short paper that is called Cataptation, or The Lost Reason of Babel. Let me read you the first line. Suppose that an archaeologist of the future finds keyboards that belong to the electronic computers only, but not to the mechanical typewriters. So, for example, he only finds this kind of keyboards. If you look at the keyboards, you write Q, W, E, R, T, blah, blah, blah. There are around, there are 2 or 3 systems of disposition. Clearly, the obvious one, that is the alphabetical order, is not available. Why is it so? There are 2 reasons underlying that. First, when they first construed keyboards that were mechanical, the typewriter were too fast. So they had to exclude the 2 statistically closed letters were closed physically on the keyboard, because it happened what happened, at least people of my generation, including myself, that when you type, the two iron thing goes clashed in the middle of the machine, and you have to go there with your hand, and then you clean, and then it's a mess. But then electronic keyboard came, so they designed the things in a way that distinct letters were the more frequent, so that when typewriting them, the probability the 2 hammer clashed were reduced to the maximum. Now, those kind of things happen to be forgotten, and because of the evolution of technology, and we now have electronic things. With electronic things, we could replace the disposition of letters on the keyboard in a much more convenient way for those who learn it for the first time, or for those who want to master it as adults. Well, it's just too expensive. It's too expensive to construct keyboards and substitute all the older keyboards, because people are used to the old one. In fact, if I had to get used to a new keyboard, I would be in serious trouble, because I'm already done with, instructed with the old one. So it could be that looking for the underlying reason of why this syntax would be like asking for the underlying reason of why this keyboard, when we lost the first information. Now, it's interesting to notice that if this speculation is correct, it splits into 2 possibilities. One is to ask whether in our species we had iron keyboards phase language before, and the other is whether the kid has it. Is it also expensive for nature to substitute organs while growing up? We know for sure that our atoms in our body are substituted every single minute. It happens that we know it with our nails, with our hair, but also with all the molecules or the atoms in our body. It's easy to find in the internet the information every 6 or 10 years, all the atoms in your body are changed. I never found a single paper addressing it in a scientific way. But let's assume that our body is made out of atoms that have a turnover of a certain kind. Well, is it the case that nature never has the possibility to substitute something? Well, no, it is. And this is the case. This horrible image that I'm showing you is a children's brain where you see the milk tooth be substituted by the other tooth of the brain, of the skull. Now, nature is able then to substitute an organ, a mechanism, that it's going to be in need of being replaced. It is not just the fact that you need extra teeth because they get used too much, because otherwise we wouldn't need glasses. We would have a milk eye, and at a certain point you would lose one eye. In fact, you have two, survive with the other, and then you substitute the two eyes. But it's never the case. Now, there is a sort of a corresponding question that you could ask in this example, which is something like, are there milk grammars? That is, are there things that we use that are different to the grammar that we are using now, in the same sense as the typewriter that were used in the iron era are different from the electronic one? You see, we are already lost, because we immediately ask, what are the empirical arguments where we can construe a theory of this kind? But one has to remind that, not to get the wrong conclusion, and not to assume that we have to look for the structure of the grammars that we have for any profound reason they may have completely lost. Now I get to the last part of the talk, where I touch probably one of the most controversial arguments that affect this speculation on the shape of grammar and the shape of the world. Because what I would like you to follow me on is the notion of negation. That is, not to be, or on human language and motor control. I would like to do the following thing. Attacking again the idea that the motor control system might have been at the core part of grammar, and that everything could have been evolved from a sort of a sophisticated manipulation of that. There is, of course, one immediate question that we have to make when we talk about negation. First of all, negation is a huge argument that for all linguists, that are expert in languages of the world, he'll correct me if this is correct or not. I mean, negation per se is an immense argument that goes from noun phrases to adverbial to clause oration. So I would like to do with the usual label, the Galilean style, and narrow, zoom in a very small phenomena which is already too big to be managed in the full. But I would like to ask, what do we understand? We understand sentential negation. That is, what we understand when I say, I do not drink milk, or it's not raining, or things like that. Well, let me reproduce once more the fundamental tension again. Language as an emancipated motor control system, because at this point you should be prepared to understand the path that I am suggesting. Now, the path that I am suggesting is a path where you will see an unexpected correlation between motor control and negation. There is, of course, a sort of a offside interest on negation per se for linguists. There are at least three distinct reasons. One I already said, but the other is that negation is arguably a unique human language trait necessarily involving the notion of truth. Taken as semantics, he would say the negation is an operator that reverses the truth condition of a statement. Well, one can argue whether or not animals have negation or just they refuse. Of course they refuse. Well, I had a dog, and my dog was able to understand no. Now, it's interesting because it's clearly the case that if you play with negation and recursion, you immediately realize how implausible it is that animals have negation in the relevant sense. If I tell you, I think I'm going to make it, you understand something. If I tell you, I don't think I'm not going to make it, same truth condition. Because you understand that I don't think I'm not going to make it is understood not only as reverse of the truth condition, but recursively so. So that like in a Rubik cube where you repeat counterclockwise the same maneuver, you get again to the same thing, to the same configuration as before. The second thing is perhaps the most important thing that I would like to suggest here. Negative statement cannot be traced back to external stimuli, for there are no negative facts. I am completely aware of the fact that I am compressing 100 years of discussion on negative facts stemming from Wittgenstein and Russell, well, Russell and Wittgenstein up to now. But what I simply want to tell you is that if I tell you that there is no Marilyn Monroe on this table, there's no such a thing as a stimulus corresponding to the non-being of Marilyn Monroe on this table. Because the same would be true if I would say there is no Ferrari on this table or Berlusconi on this table. The reaction to the scenario may be completely different, but nevertheless, you do have that sentences are compatible, are both compatible with the same state of affairs. So there's no such a thing as a negative stimulus. Of course, there may be cases, for example, if I show you a rainbow where yellow is missing, you could tell that that's a negative stimuli because the rainbow is missing. But why do you say so? Just because you know by heart what the rainbow is made of. So you just don't have the stimuli. You have the remembrance of a positive stimulus. Same thing is with digits. If I give you all the digits but 7, you probably already know I was saying 7 for some mysterious reason that you discovered. But if I give you the digit but 7, you would say that that's a negative fact, but only because you know by heart that you know the digits are 10 and so on and so forth. Okay, and then the third property is that negation can be linked to the motor system in an unexpected way. There is also a fourth property that I'm not going to discuss here, which is very surprising to me, and I ask to all the linguists in the audience if you have any counterexample. Adriana and Dominique, if you find in your exotic exploration of languages. Well, we know that, for example, we can get from an affirmative sentence to an interrogative sentence by changing the word order of an affirmative sentence. John is tired becomes is John tired by moving one element. Same thing with if sentences. If John had gone to Rome, he would have become a pope. You can delete if and get the same construction by moving the auxiliary to a different position and say, had John gone to Rome, he would have become a pope. Now, I know of no language in the world where you can get from an affirmative sentence to a negative sentence by simply changing the word order of an affirmative sentence. And this is a kind of a mystery, because it tells you the generalization that you have is that you always have to recruit a morpheme. Why is it so? I don't know. But it's, unless I'm missing some data, it seems that it holds. Well, but let's stick on the three properties. Of course, there is one thing we cannot say, remembering what we said in what was discussed in the first class. It would not make much sense to compare the activity of syntactic network of negative versus other kind of sentences, because you would say the same machinery of Broca's area and all the particularity of the network be active. So what we did was to propose an experiment where we correlated negation with action. Why did we come up with this idea? Because of a very trivial fact. Because I was exposed to a preliminary experiment that was done by Tettamanti, Rizzolatti, and others, where interpreting action-related sentences activated sensory motor representation and in a frontal-parietal network, arguably instantiating a mirror neuron system. Let me tell you how the experiment was done. The subject had to hear sentences, well, they were exposed to sentences that were lasting 4 seconds, for 20 seconds. The first one involved the mouth. I addento una mela, I bite an apple, lecco il gelato, I lick the ice cream. Then 20 seconds of abstract sentences, I remember the fact, I evaluate the errors. Then sentences made with that refer to hand manipulation with hand, I grab a knife, I break bread, and so on and so forth. What they obtained with this was an activation of the frontal-parietal, temporal-parietal system that had some interesting property. One interesting property that I cannot explain, and it sounds like a sort of a revenge of Broca's area, is that the intersection of the mouth, leg, and hand occurred exactly in Broca's area. But in all cases, what is interesting in this experiment was the following fact. Not only as monkeys, when you see someone doing an action with a certain intention, you activate the same somatotopic system that you would activate to do the action, but also when you hear the sentence expressing the action. I think you already get in your mind what the next slide will be about. I'm exploring negation. I'm exploring action. So we asked whether negation modulated the action representation. The experimental paradigm was very simple and should be simple to you as well. So subject, I mean, it was a little more complicated than this, but I made it simpler in this way. They had affirmative and negative in concrete and abstract sense. So, for example, they had sense like, now I grasp the knife versus now I do not grasp the knife. Ora afferro il coltello, ora non afferro il coltello. And then abstract sentences with adesso ricordo il passato, now I remember the past. Adesso non ricordo il passato, now I do not remember the past. So the expectation that we had, I mean, the aim that we had in our experiment was to see what was the relationship between negation and the representation of the motor system. And to cut a very long story short, I only give you the activation of a small fragment of the brain by giving you here soon a graph will appear where 4 different information. You will see yellow lines, action-related sentences, blue lines, abstract sentences, and for the 2 kind, you will see affirmative and negative sentence, and you will immediately see the result here. So here you have the signal change and the post-stimulus time. As you see here, with the abstract sentences, the negative and the affirmative sentences practically were not statistically different, whereas the motor system was completely influenced by the presence or absence of negation. Did we understand what was going on? No, but we guessed, and we had new perspective on nothing. And the summary of these results, although, was that our data on action-related sentences suggest a neuropsychological model in which negation is partially encoded by our brains in terms of the activation below critical threshold of the full representation of the corresponding affirmative meaning. Why such a baroque expression? Because of the fact that we cannot see negation as something that completely blocks the representation of an action. Otherwise, saying I don't grasp a knife or I don't bite an apple would mean the same thing to you. There has to be a residue for you to understand how the 2 things work. But at least it's important to notice that it is grammar that takes control over the motor system in a way that could not be reversed because of the fact that negation cannot correspond to anything in the outside world. So negation, a purely linguistic phenomena, is able to control action planning, and then the hierarchy of the 2 systems is one such that, in a sense, there is a primacy of grammar with respect to movement. To reinforce this thing, we wrote a paper that actually came out while I was here in Paris 2 days ago. Took a lot of effort to make it past the reviews. We sort of compared, we used a vampire-like metaphor to get the idea of where syntax, vampire are not visible. Everybody knows that vampire is not visible in a mirror, right? Because if it's not true, I mean, the title of the paper is completely lost. Assuming that you know about vampires as much as I do, in this paper, Marco Tettamanti and I suggested 2 things. First, that hierarchy being not visible to hierarchy being not detectable by our motor system because of the fact that the words are just put into a linear sequence cannot be cannot trigger any neuron system activation. So the neural system is out of syntax, at least when it comes to hierarchy. Second, when it comes to negation, a purely linguistic fact, again, is able to modulate the motor system, not vice versa, So there has to be a sort of a preliminary, in the hierarchical system that controls these two facts. Negation must come first. You take all these little pieces of my confused talk today and put them together in the way you like, because linguistics is an empirical science and we don't have any dogma to share or any truth to communicate, but still we're pursuing that. But if we want to go back to the question, how much word is there in syntax, at least let me summarize. The recursion makes it unlikely that syntax can be the reflex of structural properties of the word, especially movement, and negation, which is a purely linguistic fact, can modulate accent representation. Then we have, the question is, what exists? Syntactic properties cannot be traced back to external word properties. All in all, neither a software nor a hardware metaphor is sufficient to describe this special human phenomenon. Rather, we should conclude that when it comes to syntax, a mindware is what we're exploring now. That is nothing that can be reduced to the physical properties of the brain, nor to the abstract property of the stuff. Is there a mindware? I don't know. I mean, people have been criticized for being dualist. If I'm trialist, which I don't know if there exists. Trinitalist, it would be different, but trialist is different. But to understand what is at stake here, it's important exactly in the same way as in the first talk we discussed about what exists when a phrase exists. You remember that we said when a phrase, the abstract representation that I showed before exists, is the same thing as when we say that the representation of an atom as a solar system exists. Atoms are not solar system. The solar system is a way to capture the properties that the physical world reacts to when experimenting with certain experiments. Similar thing with syntax. But I want to conclude with the citation that to me is illuminating as most of the things that come from the person that I'm quoting here. Newton regarded his discovery of action at distance in violation of the basic principles of mechanical philosophy as so great in absurdity that I believe no man who has in philosophical matters a competent faculty of thinking can ever fall into it. Then the person concludes saying, nonetheless, he was forced to conclude that the absurdity does really exist. We don't know exactly what we are looking for, but I think that it's clearly the case that we have to ask what we're looking for when we look at the correlation between language and the brain, to be sure that we are not just trying to reduce one element to the other. It could well be that as Newton did, and the new Newton will come, or maybe he is already in the room, we don't know, excluding me, of course, but might be someone has an idea. To be honest, I certainly feel a sense of emptiness when I look at our research in language, because it's like, Achilles and the turtle. Achilles, when Achilles goes near the turtles move one step further, and you have the anxiety of the fact that he will never be able to grasp the turtle. Language is for the humans, it's our turtle. So I don't think we will never be able to grasp it, but I am optimistic enough to think that at least with the effect, with the choral efforts that we're going to put into that, we're going to get close enough to the turtle eyes at some point. And thank you for being here.